this section is on 1.5, graphing sine and cosine functions. So we are going to graph the functions and the different transformations that it does. This would be familiar in Algebra 2 when you were graphing equations there, dealing with transformations. So hopefully you will remember some of this stuff, except with, it's not with Algebra 2 concepts, it will be with sine and cosine functions. So a couple of things that we need to know about the graphs. The graphs look very similar, and without the x and y axis, you actually cannot tell them apart. So whenever you graph these and when you look at them, and I look at them for homeworks, I'm going to be looking at the x and y axis to be able to tell which is which. The graphs do actually model real life situations, anything to do with seasons, light waves, sound waves, anything like that. One thing to note is the x-axis is measured usually in radians, so we're going to use radians, and then the y-axis is just measured in numbers, so like 1, 2, 3, 4, 5. This is the basic form of the equation. Y equals a sine bx minus c plus d, and the a, b, c, and d all mean something. So the A is the amplitude. The B is a stretch or shrink. So it is a change in the y value. The C is a horizontal transformation. Actually, it's a horizontal shift. So that is a change in the x. And then the D is a vertical shift. Show whether it goes up or down. Okay, so if we wanted to graph y equals sine of x, and you just wanted to graph it using a table, then for the x values, remember it has to be in radians. So if we think back to the unit circle, see, this isn't going anywhere, that, and we look at the axis points, then we started at 0, then we went to pi over 2, then we went to pi, then we went to 3 pi over 2. So remember that's 0, this is 90, 180, and 270. So then if you would go to put those in your calculator, sine of pi over 2, sine of pi, sine of 3 pi over 2, sine of 0, or you would look at your unit circle, or look at your blue sheet, because we have those on there as well. This would be 0, 1, 0, -1, and then I guess I need another one, 2 pi would be 0. So whenever you go to graph these, one thing to note, especially in these notes, is this graph paper is very small. So I like to use 3 boxes, I guess, for like 1 hash mark, just to make it bigger. And then each hash mark is going to be the x value. So this is 0, that's pi over 2, that's pi, 3 pi over 2, and then 2 pi. And then if you remember from the last slide, it said the y values are always going to just be numbers. So we would have 0, 1, 2, -1, and -2. And if I would just plot these points, you start at 0, 0, and then pi over 2, 1, pi, 0, 3 pi over 2, -1, and 2 pi, 0. And if I connect them, that's what it looks like. I kind of think like it goes up and then it goes down. It looks like a wave. This is what I like to say. It looks like a wave. Okay. If we would go, and then here's the sine graph, it's continual. So if it just keeps on going. Okay, if I would do the same thing with the cosine graph, I'm going to use the same x values. So we're still going to use the 0, the pi over 2, pi, 3 pi over 2, and 2 pi. Remember, these are the axes on the unit circle. And then same thing, if I put those into my calculator, I looked on my unit circle, I looked on my blue sheet, you would find that the y values would be as follows. Going to graph this, I'm going to do this every single time, marking out 3 blocks for each one. The x value, x-axis is going to be the pi over 2, pi, 3 pi over 2, and 2 pi. And then the y values are just going to be the numbers. So when I go graph this one, and connect them, it looks like a U, looks like a valley. So looks like a U or a valley. So you can see that they look different when you have the X and Y axis, but they do not look different if you do not have the X and Y axis, because it just keeps on going. Okay, so here are the transformations. This will be a little bit of review from Algebra 2. If you are inside of the parentheses, you're going to go left or right. So if you have a C value, you will go left or right. And it's actually backwards than what you think. So if you're a plus, you think that you're going this way, but you're actually shifting it to the left. And then if you're a minus, you think you're going to the left, but you're actually going to the right. And then the outside, if you are adding or subtracting, then you're just moving up or down in your graphs. And then if you have a negative out front of the A, then you reflect about the x-axis. So basically, you're just flipping it over. And we will come back to this, I think, tomorrow, whenever we add in the transformations. Okay, so amplitude is one thing that we have to find before we do anything. So this should be the very first thing you find in your graph. It's how high or how low the graph goes. So technically, it's the distance from the center line of the graph. So whenever you have the function f of x equals a sine wx, the amplitude is a. So it's always that number in front of the function. So number in front of the function. And it's just how high or how low it goes. So what number is in front of the sign here? It's a 1. So the amplitude is 1. And if you look from the center point of your graph, it goes up 1 and it goes down 1. So if we look at these two examples, and I have y equals 5 sine of x, what is the amplitude? The a is always in front of the function, so the amplitude would be 5. And if you look at the graph, it's how high and how low it goes. If you look at the next one, you have y equals 10 sine of x. So again, amplitude is 10. How high and how low? Okay, if the amplitude is less than 1, the graph compresses, and if the amplitude is greater than 1, the graph expands. So basically what it's saying is if the amplitude is less than 1, then it shrinks vertically. And if it's greater than 1, then it stretches. Okay, period is another thing that we need to figure out before we graph anything. So the period is the length that shows when sine or cosine starts to repeat itself after starting at x equals 0. So if I look at this graph right here, I'm starting here. If I continue to follow the graph until it starts to repeat itself, it starts to repeat at 2 pi. So that would be my period. So in order to figure out what your period is, use this little formula right here. So period equals 2 pi divided by b. B comes from the equation, and it's the number in front of the x. So if we look here at this example, f of x equals 2 cosine x over 2. The number in front of the x is 1/2. So if I find the period, p equals 2 pi over b. So you get 2 pi over 1/2. Have to multiply by 2 to get that out of the denominator. And 2 pi times 2 would be 4 pi. So that would be the period. In the second example, negative sine x, or negative sine negative 3x. B is negative 3. So the period would be 2 pi over negative 3. Pretty simple. Okay, so this is the steps for graphing. The very first thing you're going to do is find the amplitude and the period, which is what we just did. And then step 2 is labeling the y-axis based off the amplitude. So if your amplitude is 10, you're probably not going to number the graphs by 1 because you're not going to have enough room. So you have to think about that. And then step 3, you're going to make the hash marks on the x-axis and then labeling the last mark using the period. And I'll show you that that's how we start it. And then if it helps you to make a t-chart, you can. And then draw the curve based on the trig function. So if we look at this first example, we have y equals 2 sine x. We need to figure out the amplitude and the period first. So the amplitude is, if I draw this example, actually, the original y equals a sine b x minus c plus d to look at the things. Amplitude's always that number in front of the sine. So your amplitude is 2. Your period is the formula 2 pi over b. And b is always that number in front of x. So what number is in front of here? It is a 1. So it would be 2 pi over 1, which is just 2 pi. Okay, so you're ready to graph this now. You're ready to label your x and y axis. So if you start with your y axis, remember I'm always using those 3 hash marks so I just have room in my notes. My amplitude is 2, so I can count by ones. And then my x-axis, I'm going to make 4 hash marks. And your period is always going to be this last number, and that is where you want to start. And then you're going to make your way back in. So what is half of 2 pi? What's half of 2 pi? What is half of pi? Pi over 2. And then what is between pi and pi over 2? So what is between 1 and 2? 1.5. So that would be 3 pi over 2. Okay, so if you make a t-chart, and this is if you want to, I normally don't do this, but
end of age lunch.
You have x and then 2 sine of x. So your x values are 0, pi over 2, pi, 3 pi over 2, and 2 pi. The original function is sine x, and then we need to change the amplitude to 2 sine of x. So if we think back to the original graph when we just had sine x, we had 0, 1, 0, -1, 0. All you're doing here is multiplying it by 2. So 0 times 2 is 0, 1 times 2 is 2, 0 times 2 is 0, -1 times 2 is -2, and then 0. This now is going to be your x and your y, your ordered pairs. So you'll have 0, pi over 2, 2, 0, -2, and 0. And if you look and compare, it looks exactly the same as the original sine function, except the amplitude is now 2. A sine graph should always look like a wave. And depending on what the amplitude is, it's going to go higher or lower. But I think making a t-chart would be the best case scenario. Okay, so going on to the next example.
Start of lunch.
We have y equals 4 cosine 2x. So I'm going to look for my amplitude and my period first. So if I remember to look here, we have y equals a sine bx minus c plus d. So amplitude is always that number in front, and so it's a 4. Period is 2 pi over b, and b is that number in front of the x. So it would be 2 pi over 2, which would be pi. Okay, so you're ready to make your t-chart now. I'll try and make it small enough and a little bit more organized here. So we're going to have your x value. Then you're going to have the original cosine. And then you're going to have the transformation. Okay, now something to think about is the 4 is what is changing the y value. The 2 is what changed the x value. So we actually don't need to worry about this part whenever we fill in the t-chart. So whenever we go to fill this in, you're always going to start with the pi at the end because that's your period. Then you're going to work your way in. So what is half of pi? Pi over 2. What's half of pi over 2? So what's half of 1/2? Pi over 4. And then what is between 1/2 and 1? 3 pi over 4. So your x values are 0, pi over 4, pi over 2, 3 pi over 4, and pi. Okay, looking back, the original cosine y values are 1, 0, -1, 0, 1. Hopefully you will end up memorizing those because it will be a lot easier and we use them so much. Then finally, we are just going to take the 4 and multiply it by these numbers. So 4, 0, -4, 0, 4. Now when we go to do our y-axis, I don't have enough room to count by 1s. So I'm going to count by 2s. And then when you graph, it's going to be this one and this one. So 0, 4, pi over 4, 0, pi over 2, -4, 3 pi over 4, 0, and then pi 4. And when you connect the dots, it looks like that U. It looks like that valley. That should always happen. Okay, I have one more. So we have y equals negative sine x minus 1. So if I look at the original, y equals a sine bx minus c plus d. Finding the amplitude, it's always that number in front. So it is a 1. Don't get that negative confused because that means something else. The period is 2 pi over b. And the b is that number in front of the x, which is a 1. So it's just 2 pi. And then this minus sign and the -1 are transformations. So if you remember looking back at the transformations on the first page of the notes, you have a negative sign means it reflects. So that means it flips over, basically. And then that -1, it's on the outside of the parentheses, so that is a D. So that means it shifts down. So whenever we make our T-chart, we're just going to have to make a couple more parts of the graph. Okay, so I'm going to make my hash marks. Always start with your period at the end. So my period's 2 pi. Half of 2 pi is pi. And we got pi over 2. And 3 pi over 2. Amplitude is 1. So now we have to just figure these out. All right, so you got your T-chart. You have the original sine graph. Okay, then each part afterwards is going to be a transformation. Do you multiply or subtract first? You multiply. Speaking of order of operations. And then you subtract. So our x values original sine numbers are 0, 1, 0, -1, 0. Again, just like cosine, I'm hoping that you memorize these. Okay, then what's the difference between here? You multiplied by -1. So 0, -1, 0, 1, 0. What's the difference between these two? Is you subtracted 1. So let me write that down. Subtract 1. 0 minus 1 is negative 1. Negative 2. Negative 1. 0. Negative 1. Okay. So this is what you are going to graph now. So 0, negative 1, pi over 2, negative 2, pi, negative 1, 3 pi over 2, 0, and 2 pi, negative 1. So if you look at this one, it still looks like that wave, except it's reflected. So it's flipped over and it's shifted down. Okay, so it's time for your homework. You have 4 graphs that you need to graph. Please make sure you pay attention to these because each of these numbers have a part to it. So make sure for 25 you only do the g of x and then the f of x. You can graph 4 graphs on the same piece of graph paper. You do not have to use one big piece of graph paper for one graph. You can fold your paper like a hot dog and then fold your paper like a hamburger, and you'll cut your paper up into 4 different pieces, and that's how you can graph those.